Hi, and welcome to class 6. Wow, we're like already 6 classes in of developmental psychology, Psych 250, NDSU summer semester 2017. Um, just to kind of update you on your progress, this represents classes 11 and 12 of a normal 16-week, 50 minutes, 3 times a week class. So we are buzzing through information really fast, but I'm confident that you're doing really well. The quiz scores were really good. The discussion posts are very insightful, so I'm not worried about you at all. So, good job, everyone. I think so. Everyone took the quiz. Let me look. I was going to check this before class started, but um, let's see. Just want to make sure I'm not like flashing anyone's grades up on the screen here. Um, so everyone took the quiz, and then it looks like everyone did the discussion board. So that's good. Wonderful. So good job everyone for completing all the work. I'll make sure that your grades are put in as quickly as I can get them in. One person did not take the Tell Me About You survey. I'd appreciate it if you would go in and do that. If you take it by the end of this week, I will give you a quarter of a point extra credit on your midterm exam. But please do that so that I can get your name and pronouns correct, and just so I have a little bit of information about who you are. All right. So we're going to today talk about development in terms of physical and cognitive development in infancy and toddlerhood. And I picked this picture as our theme picture of the day because I just love it. This little baby, not sure how old they are, probably about between 1 and 2 years old, at the Women's March in Washington, D.C. back in January. And the baby is holding up a sign because they know they have something to say. They don't know what they're protesting, but they know they have something to say, and they said it in the way that they could. And I just think that that is such a beautiful picture of what cognitive development is like for and language development is like for very small infants and toddlers. So I just thought this was a great picture to exemplify what we're talking about today. So we will be talking about physical and cognitive development in infancy and childhood, or sorry, infancy and toddlerhood. We'll cover a fairly small amount of time within this class. I'm estimating that we'll actually finish this class early today as well. So you're welcome. Don't get used to it. It just kind of depends on how much material there is to go through. And I could be surprised I could talk for a lot longer than I think I will. But you'll notice on the syllabus that I tend to combine the physical and cognitive development together because they're so inextricably bound to one another. Because physical structures develop, the cognitive development then, or not necessarily develop, but they mature and they grow more sophisticated. Then the cognitive processes of an individual also get better, more sophisticated. So you'll notice that we'll talk about these in tandem most of the time throughout the semester. But let's start with physical development first. As an infant and toddler grows, they increase in size by 50% within the first year and 75% within the second year. So rapid growth, 50% means they're going to be um, um, the size that they currently are. They're going to be half that. They're going to be that size plus half of that size by the end of the first year, and by the end of the second year, they're going to be the size they started plus 75% of it at the end of the second year. So that's a lot of growth that occurs in the first 2 years of life. We do see group differences emerge, though, between with these infants. So, for example, girls have a higher fat to muscle ratio than boys, and this is a difference that we notice throughout the lifespan. And part of the reason for this is, of course, the fact that girls and female bodies are equipped to carry another person through the pregnancy process, and so it's necessary to have more body fat in order to maintain a healthy pregnancy. Also, we see group differences among ethnic groups. So different ethnicities differ in their average weight and length. And so we do see some differences in terms of physical changes that occur based on a person's ethnic group. We do see changes in body proportions as infants and toddlers continue in their physical growth. The first trend that we see is a cephalocaudal trend, and that is when the head is larger proportionally than the trunk. So the head, the trunk being the rest of the body. And if you've ever seen a small child, you'll probably have seen this. They look like a bobblehead. Think of like Stewie Griffin, like huge head, tiny body, and that is what the cephalocaudal trend is. We see head growth a lot larger and a lot faster than body. We also see a proximal trend, and this is when the head and trunk grow before the arms, legs, hands, and feet. So as the physical development progresses across those first 2 years, we do see the head and the trunk. So uh, like the chest and the abdomen, well, not the legs, but the the part to which the legs are and arms are attached is the trunk. So that grows before the arms, hands, and feet. So little tiny children often seem very disproportionate looking, and that's because of the growth trends that they experience. We also see, in terms of other physical growth, we see brain growth. So um, let's talk about different brain structures. And if you've had intro to psychology or any other psychology course, you've probably been introduced to these terms. But neurons are nerve cells that store and transmit information. And these neurons connect to one another. And so let me draw you a little. Do I have a diagram? I do not have a diagram. Okay. So let me draw. Go away. So let me draw a little diagram for you. So the neuron looks something like this. You've got the cell body of the neuron, and you've got uh, the nerve. Excuse me. And then you've got these little dendrites right here. And they have neurotransmitters on the end of them. So you have the cell body, the axon, and then the dendrites with the neurotransmitter receptors. And then they put out these neurotransmitters, which are just little, I guess, proteins or hormones, whatever you want to call them, that send different signals. And there are some neurotransmitters which um, um, aid in feeling uh, uh, sorry, it's like early in the morning. So for example, some neurotransmitters will, if you have too much of it, will cause you to feel depressed. If you have too little, it'll cause you to feel depressed, because they transmit different information about different emotions, uh, different states of awareness, and so those neurotransmitters are really important. And so you have neurons that form your oh God, I need more Diet Coke this morning. Nervous system. And so what we have is we have like a bunch of different neurons. And so right here, we would have another neuron with its own set of dendrites connected to the cell body by the axon. with different neuroreceptors. And so this neuron is sending neurotransmitters to this neuron, which is also sending its own neurotransmitters to this one. And so this transmission of information is what causes us to have cognition, to have thought. Um, this gap that exists between neurons, this gap right here that exists where the transmission occurs between neurotransmitters is called a synapse. So this gap that exists between this connection where the neurons are transmitting neurotransmitters, this is called a synapse. Myelination is the fatty sheath that coats the neurons to make the transmission more efficient. So you think about, I don't know if anyone here is really that familiar with like electricity or, how electricity works, but um, if you have an insulated cable, the electricity transmits or flows a lot more efficiently because there's not any kind of interference. And so it's sort of the same idea. The cell is sending impulses down to these neuroreceptors, which are sending out the neurotransmitters. And so over time, as a person develops, this axon and the dendrites get covered in this fatty substance, which is like an insulation, which makes it more efficient. So that's occurring during this period of time. So this yellow is a fatty myelin substance. Now, over time, there are a lot of changes in the brain. Um, infant and toddler brain, the infant and toddler brain is very plastic, highly plastic, which means it's adaptable. It's constantly growing, it's constantly changing, and infant cognition is constantly growing and changing. And there are sensitive periods of brain development that affect healthy development. And so, what I'd like for you to do as a bonus for your participation today, if you would explain to me what a sensitive period of brain development is. I'm not going to say it. I'm going to let you figure it out because we've already talked about sensitive periods. So add that, you'll get 0.25. Let me write this down because last time I had to go back and watch the video to see. Class 6, 0.25 if you explain what a sensitive period is. So just tack that on to your discussion for today. There can be a lot of different influences that occur in relation to a person's physical development. So the first is heredity. How your genes are, what your genetic makeup is, how your family has developed physically is a huge influence on your physical development. So if your parents are both incredibly small, you may not see as much physical growth in those early years because your parents may just not have transmitted those genes to you for height and weight. Nutrition also plays an important role. So infants who don't get proper nutrition can have differing patterns of physical growth. So infants that have healthy diets are going to grow a lot faster than infants who don't have healthy diets. Malnutrition is also a really big influence on physical development. And unfortunately, malnutrition in infants and toddlers is a very prevalent worldwide problem. There are two different types of malnutrition that could affect the physical development of an infant or toddler. The first is marasmus. This is a wasted condition of the body due to nutrient deficient diets. Um, so that's an example of a child with marasmus. I believe this child's in Somalia. Um, there's a um, really bad civil unrest there, a lot of poverty, a lot of violence that affects the people who live there, and this is the example of what that does to, a child caught up in that conflict. Very much nutrient deficient. You can see their bone structures. They're not getting adequate food or nutrition. Another type of malnutrition is kwashiorkor, and this is a wasted condition of the body due to low protein diet. So it can also look very much like marasmus. Marasmus, though, is nutrient deficient, whereas kwashiorkor is specifically low protein. So you may be getting good nutrients from like vegetable proteins, but you're not getting animal proteins. Or your diet consists mostly of sugars and starches, but you're not really getting any vegetable or animal protein. And then emotional well-being can also have a huge impact on physical development. And we have a condition called non-organic failure to thrive. So non-organic meaning it's not based on any kind of organic imbalance, such as lack of food or some other kind of physical or environmental toxin or environment. It's based entirely on an emotional or psychological deficiency. And this is a growth disorder that stems from a lack of parental love. And basically it's marasmus, but it doesn't have an organic cause. So there's not like it's not because of nutrition or toxin, it's because they're not being loved by their parents, so they have this wasted condition of their body. Infants and toddlers are very susceptible to classical conditioning, which makes their learning capacities very, very sensitive. Um, just to refresh our memory about this, different forms of classical conditioning include operant conditioning, and this is the response to behaviors that will be related, or that proposes that the responses to behaviors will be related to the likelihood of it occurring again. So, for example, a child who rushes towards the street, if mom or dad freaks out, they're probably not going to do it again. Um, it may take a couple times for that to happen before the child makes the connection that it's not okay, but over exposure to something over and over again does increase or reduce the likelihood of it occurring again. And it does so through the use of reinforcers or punishments. And reinforcers are stimuli that encourage behavior. So if you want a child to eat their vegetables, you make a huge deal out of it when they do eat it. So like the child eats the broccoli, "Oh, you ate your broccoli, that's so good, you're such a good child." That's a reinforcement because you're making them feel really good, you're increasing their self-efficacy because they've eaten the vegetable, and that is a reinforcer. It reinforces that it'll happen again. A punishment is the removal of a desired stimulus or the introduction of an unpleasant one to discourage behavior. So, for example, if a child wants a toy, but you don't want them to scream and cry for it, and they scream and cry for it, and you take it away and you don't give it back, that's a punishment. And over time, if that happens multiple times, the child's going to make that connection that, oh, if I want this, I need to be polite about it. I don't need to try to like throw a tantrum. Or introduction of an unpleasant one. So a child doesn't do what you say, so you put them on timeout, which is the most effective form of punishment, much more so than spanking. Over time, introducing that punishment will cause the child to condition to not doing something because they don't want to have that punishment applied. Now, over time, habituation may occur, and this is a reduction in the strength of a response due to repetition. So, for example, if after a time being praised for eating broccoli is not going to be as like is not going to be as novel, and you're going to be like, okay, this is boring. I don't really care if I get a pat on the back for this. And so what you do then is you ramp up the stimulus, so the reinforcer or the punishment. You do something stronger. So the child eats their broccoli, getting verbally rewarded for it has become blasé or boring. So you give them something else, like, oh, well, because you did this, now you get strawberries or you get chocolate or something. So that's more of an incentive. And over time, though, you start to uh, uh, it becomes a habit and you don't really need the reinforcer or the punishment anymore. Along with conditioning, classical conditioning, infants and toddlers are highly susceptible to imitation. And imitation is copying the behaviors of another person. And we've all seen this. You see an infant or a toddler in the store, you make a face at them, they might make the face back because they're imitating. They're learning how to do what you're doing by imitating it. And this happens through a cognitive process that uses what are called mirror neurons. And these are sets of neurons which mimic observed behaviors and cause infants to imitate those behaviors. And so essentially what happens is when we observe other people and we see their behavior, our brain subconsciously mimics that behavior. The neurons that would do the same behavior on us, so like making a face like this, like if you were to see that or you are seeing that, so when I do this, the neurons in your brain that control this reflex in you are subconsciously reacting to that, and they're practicing that expression as if you were doing it. And what's really cool about that, and we'll talk more about this when we talk about emotions and empathy, is when our mirror neurons react in such a way, like when it comes to another person's pain, we start to feel that pain. We start to feel that emotion because our brain is walking us through the steps of what it would take to experience it. So it's actually incredibly interesting from a psychological perspective how this works. What I'd like for you to do for your discussion board, I want to build on last week's material, which will help you on the midterm, hint, hint. But I'd like for you to consider the following. Infants and toddlers are always learning. So what I want you to do is design an experiment in which you test the question, does reading to children every night improve their vocabulary? I'm not going to tell you how long this needs to be because there's not a right or wrong answer to that, but you do need to review Lecture 2 to refresh your memory on your understanding of what needs to be included in an experimental research design. Okay, so you have a lot of freedom here to design your own study, but it needs to be an experiment and it needs to have all the required elements of an experimental research design. Now, you'll get 1 point for completing the discussion board. It doesn't matter if it's right or not. But I will give you an additional point if you complete it correctly. So keep that in mind. You can get another discussion point if you just do it correctly and include all the required elements. So make sure that you look at Lecture 2 to make sure that you have all the information that you need. And then if you get an extra point, that means that's one less discussion board you have to do towards the end of class. Okay, you have that down. Let's move forward. Let's talk now about motor development. So we've talked a lot about physical changes, but what about physical competencies, our ability to use our physical development to get what we want? And so there are two different types of motor development that occur. The first is gross motor development, and these are actions which facilitate movement and exploration. So walking, for example, is a gross motor development. Reaching is gross motor development. Um, well, I guess reaching in the sense of reaching and pulling yourself would be an example. I'm thinking about for infants and toddlers. Fine motor development are delicate actions such as reaching and grasping. So like reaching out for something, that's fine motor development. But if you're reaching, grasping, and then pulling, that would be motor development, gross motor development. So picking up a pencil, for example, this is very delicate. It's fine motor development. Drawing with it, it's fine motor development. The dynamic systems theory of motor development proposes that mastery of motor skills involves increasingly complex systems of action. So, for an infant and toddler, early gross motor development may include like stepping, whereas over time when you master stepping, you may move on to actually walking or toddling along. Toddling is sort of that weird like walk and like stumbly walk that toddlers have, which is why they're called toddlers. Um, Fine motor development, an example of dynamic systems theory, or what dynamic system theory would explain is that initially you may like be able to grasp a pencil, but not very well, and then over time as you master grasping it, you might be able to start drawing a little bit with it. And then as you learn to draw a little bit with it, then you could maybe do more accurate drawings. So, as we learn, as we master, we get better at it. And this is from your textbook, but there are a lot of different gross and fine motor developments that occur within the first 2 years. So, when held upright, you can have your head erect and steady. That would be an example of a fine motor skill. When prone, lift self by arms. That would be an example of a gross motor skill. Roll from side to back. That's another gross motor skill. Grasp a cube. Fine motor skill. So just go through this, and you don't have to submit this information, but I want you to look at this table and think about what each of these examples, what kind of motor skill it is, because you may have to do this on the exam, and I want you to make sure you understand what you're doing, okay? Let's move now into cognitive development. A large part of cognitive development for infants and toddlers involves perception. And perception is... I recently interacted with a person who told me that the world is all about reality and that perception doesn't matter. And I found that really hilarious as a psychologist, because as you'll learn throughout the semester, all that we are as human beings involves our perception of what's going on. Perception is the way that our brain categorizes and explains what it's receiving through sensation. So, sensation being watching something, seeing something, hearing something, tasting something, feeling something. Our brain takes all that information that it receives and it categorizes it and it seeks to explain it based on our understanding. Um, and so it's kind of funny when people say, well, there's no such thing as perception. It's like, false, because everybody's physical and psychological and environmental and emotional and biological experiences influence how we perceive things and how we understand things. And as we grow as infants and toddlers, we become much more adept at our understanding of things through perception. Hearing is one of the ways that infants develop perceptually. With hearing, infants organize sounds into increasingly complex patterns, and by 6 months are sensitive to their own language. So we think about sounds like this is a very simple sound, right? There's not a lot of variation in it. But if we have something like this, that's very complex. And so infants are able, and you probably as well, could pick out the differences between, and so you're organizing those two sounds into two different ways. And then again, sensitivity to your own language, you're able to pick out, you may not understand what someone's saying, but you're able to say, hey, that person's speaking my language. You wouldn't probably have the word for language, but you'd recognize it as a 6-month-old. Oh, that person, I should go with that person because they sound like what I'm familiar to. Vision develops very rapidly. We talked about as a newborn, very small infants are not very adept at vision acuity because you don't really have to use your vision in utero in the way that you use hearing and touch. Um, but we do see this develop very rapidly in infancy and toddlerhood. Focusing, color discrimination, and physical visual acuity develop very rapidly during this period, as does depth perception. So our ability to look at something and kind of make a judgment about how far away it is, how deep it is, how wide it is. Along with depth perception, infants and toddlers develop responses to motion cues. They see something going on over here, they're going to look. Whereas when you've got a newborn, you do this, they may or may not look. If they look, it's just because they're looking around. They're not really responding to you. So like if, something over here is like that, so you're going to react to it. You're going to look and see what's going on because you've developed a response to motion cue. And then sensitivity to binocular pictorial clues. Binocular being you have this sort of, we can see about from here like this. Whereas monocular is, if you were to close one eye, you've got a very limited scope right in here. Well, you got to go right here. Infants also develop contrast sensitivity, so the ability to distinguish patterns, to distinguish differences in the way that things look. So everything's not just one like monochromatic experience. We have different colors, we have different textures. Um, by 2 to 3 months, infants are able to examine external features of patterns. They're able to tell the difference between check marks, like checks and circles and polka dots. By 2 months, they're able to recognize and prefer mom's face to anybody else. Now, when I say mom, really that's primary caregiver. So if dad's primary caregiver who's spending the most time with child, it's going to be dad's face. Um, there's nothing intrinsic about a mother's face. It's just that that's the face they see the most. 3 months recognition of facial features. So where's your nose? They might be able to, if they understand the word for nose, will be able to pick it out. They're definitely going to be able to see that, oh, this is different than this. 6 months distinguish between emotional facial expressions. So by 6 months, they have a pretty good grasp on if you're mad at them or if you're happy with them. We also see development of intermodal perception, and this is comparison across senses. And that means that if you're getting a perceptual input from your ear and you're also getting it from your eye, you're able to make sort of a composite of those two. So if you hear like, a siren and you see people's scared faces, and the siren is scary and loud, you're going to intermodally perceive that there's something scary and bad going down. Um, Whereas prior to the development of intermodal perception, you may not be able to make the connection between the scary noise and people's faces and people's facial expressions. Now, according to the differentiation theory, infants impose meaning on what they see. So, in other words, infants aren't just mindless blobs of cells that are taking in information. They're actually making their own meaning. Their perception is going the same way it does for adults. It may not be accurate, and that's the thing about perception is it's not always accurate. Um, and perhaps that's what the person I was talking to, I'm not going to say they were my friend. This person contacted me unsolicitedly to tell me that I was an idiot. But perhaps that's why they were trying to convince me there's nothing but reality, because their perception was different than mine and they were uncomfortable by that. But infants are imposing their own meaning. It may not be accurate, but it's based on their own experience. A researcher by the name of Campos really had this really clever experiment where he tested the ability of the infant to one distinguish between different patterns, to experience depth perception, and to make judgments based on what they're seeing, as well as using intermodal perception. And what he did is he created this table, and the table had the same pattern on it. And then there was this visual cliff. So the table did like it was sort of, well, it was a table. So there's a platform that goes like this, and then it went down, and then there was a bottom, and both the top and the bottom had the same pattern on it. But then there was this clear glass or plexiglass so strong plastic, over the cliff. So the infant wasn't going to actually fall down. But he put the infant on the table, and he had the mother of the infant on the other side, and the mother would call to the baby, and the baby would go. And based on how old they were, very young children would just continue across this cliff. They didn't care. They couldn't tell that there was a depth difference. They couldn't distinguish the difference in pattern. Um, they were just going off of what the mother was telling them to do. But as they got older, even if the mother was telling them to do it, they would see the cliff and they'd be like, "No, I'm not doing that." So what I'd like for you to do, and this link will be in your handout, but watch this video for an example of that. It's a pretty cool experiment. Over time, there are some pretty important cognitive changes that occur for infants and toddlers. By 8 months, we start to see goal-directed behavior. Goal-directed behavior are any types of actions which form some kind of pattern based on what the goal of the person is. So if your goal is to make an A in the class, then you're going to engage in behaviors that will get you an A. So for infants and toddlers, if you want to play with a toy that's in the other room, you're going to make your way to the other room to get it, and you're going to come back and get it. And before 8 months, people or infants just don't really do that. They only go with what's at hand. They don't really have a lot of thinking plus action combination going on. By 8 months, we're also, as human beings, aware of object permanence, meaning that this object right here, this little pen, exists whether or not it's on the screen. So someone under the age of 2 months, if I go take this and then like look at this little pen, and they're looking, and then it goes, where did it go? And they could talk, they would say, well, it's gone. It doesn't exist anymore. Whereas it's just sitting in my lap right now. Um, by 2 years, um, infants start to have mental representations. They're able to, in their mind's eye, picture the object that they're thinking about. Oh, what does Ernie look like? And they can think about Ernie in their head and say, oh, well, Ernie looks like this. Um, from Sesame Street. Are you familiar with the Sesame Street? It's a pretty great show. You should watch it. Um, by 2 years, object permanence is pretty firmly established. So at 8 months, it's starting to be there. Infants can still be puzzled by it, but by 2 years, you're completely aware that something exists, whether or not it's present or not. And this is why young children under the age of 2 get very upset when mom and dad leave, because they don't believe that mom and dad exist anymore because they're not there. So that explains. Now you're traumatized. I can never leave my kid again. They think I'm dead. They think I'm gone. Apparently, dogs and cats also feel. Well, cats don't really care, but dogs get really distressed when you leave because they feel like you don't exist anymore. I don't think dogs have object permanence. Um, Deferred imitation is another thing that starts to happen. And if have had children, or you have younger siblings, you have, I promise you, experienced deferred imitation. And this is when a child sees a behavior that they would like to imitate, but they don't imitate it right away. So, a perfect example is going to the supermarket. We've all been there. There's that one parent who's like overwhelmed and tired, and their kid is screaming because they want a candy bar. I want the candy bar! And the parent's just ignoring them, and everyone in the grocery store is like, "Oh my gosh, I don't want to have kids." You could like just feel your eggs like shriveling up and dying. Um, and your little child sitting in the cart being so well behaved. You're like, look at my kid. My kid's well behaved. I'm a good parent. Parent of the year over here. But that child's taking that in. They're like, I think that's really effective. I'm going to file that away and use it later. Especially if the child gets the candy bar in the end. They're going to be like, oh, well, it definitely works. I'm totally going to do that. And so next week when you go to the grocery store, you're the parent with the screaming, obnoxious child. And suddenly you go from being parent of the year to pariah of the year. So deferred imitation is a wonderful thing. Make-believe play also is very prevalent by 2 years old. And again, this goes along with mental representation and imitation. The child is acting out social situations that they've observed in real life, that may or may not involve physical or tangible objects, but they're able to represent them in their mind. And make-believe play, as we'll talk about next time, is really important for emotional and social development. René Baillargeon at um, University of Illinois is a researcher who's done a lot of work looking at infant and toddler um, object permanence, mental representation, and she did this really cool study, and I've included a link here for you to watch, about an unexpected event. And what Baillargeon did is she had infants sit in their parents' lap and watch an event. And during this event, she used a mini doll, it's a Minnie Mouse, and Minnie behaved in an expected way and in an unexpected way. And then she watched the amount of time at which the infant attended to or looked at the experience, the event, and she found that older infants would look at the event, the unexpected event, specifically the mini doll. Um, you'll have to watch the video. It's hard to explain, but essentially what happens is there's this little doorway on this puppet show stage, and there's a mini doll, and the mini doll is shown to the baby, and then it goes behind the wall of this little doorway, and then you don't see anything occur inside the doorway, and then Minnie comes out the other side, and the infant's like, "What? That doesn't work." And what's happening is there are actually two dolls, one behind the other side of the wall, and then it's like here's the doorway, so there's a mini doll here. So this mini doll comes in, the one that they're aware of goes behind the wall, and then this one comes out, and so the infant's like, "Wait, what? That doesn't make sense." But it's only for older infants. It's not for younger infants. So this was a way of her demonstrating through an experiment that there are differences in the way that infants and toddlers perceive things. So watch this video. It's a really neat experiment. Maybe it'll give you an idea for how you can create experiments for your discussion board or other things that you might have to do. In terms of theories related to cognitive development, um, Piaget proposes that infants in this stage are in what's called the sensory motor stage. And this means that there's a circular reaction that allows infants to adapt schemes to reflexes and flexible action patterns. In other words, cognitive development during this period is a process of taking in information, adapting it to our way of thinking, and then regurgitating that information in the form of an action. Schemes, this is probably a new term for us, is a way of organizing information through adapting information. So the best way to think of a scheme is like this. It's a file folder, okay? Your scheme is a collection of information that you have. So say you have a scheme for sodas, or pop as they call it here. So you see a Diet Coke and you're like, oh, I'm gonna put this Diet Coke in my folder um, for sodas, and you keep doing that, and then you come across like a juice, and you're like, well, it's in a soda bottle, but is it really a soda? I'm not really sure. And so when you're looking at this isn't actually juice. It's one of those little, like, I don't know, cool little therapy things that helps you relax somehow, maybe. Um, Someone gave it to me, and I just have it because it's cool. But assimilation is using your scheme, so using the information in your folder to understand what this is. Accommodation is adjusting your scheme to information. So you see this and you're like, well, it looks like a soda, but it's not really, it doesn't have the soda bubbles. So I don't think it's a soda. Maybe it's just another kind of beverage. And so then you would make a new scheme. You'd say, well, I'm going to call this scheme my other kinds of beverages scheme. So you have a different folder that you would put this in, and that would be accommodation. Coming up and adapting your scheme to meet new information. Conversely, you could just take this folder and say, well, I'm going to take soda off of it and just put beverages, and just put this in as a beverage. In terms of the information processing theory, it proposes that we use mental strategies or ways of categorizing information and using it. And so information enters our brain through a sensory register, so our fingertips or any of our nerve endings, our eyes, our ears, our mouth, our nose. And then information is stored in working or long-term memory. So working memory is sort of like a desk. Think of your brain as an office, and working memory is the desk. It's the information that you need to attend to, that you need to think about right now in order to do the process. And so your information can sit on your desk while you're working, or it can go in the filing cabinet. In the filing cabinet, it's your long-term memory. This is information that you need to remember, but you probably don't need to know it right now. And the cool thing is that at your desk sits what's called the central executive, and this is a process that manages your information in your working memory. So your central executive, when the information comes in is like, I need to know about this information, so I'm going to put it on my desk. But this other information, this I can put in a folder and put in my filing cabinet. At the same time, as we're going through our experience, we might recognize new things, or we might see a stimulus and recognize it for what it is. And this involves the central executive going to our filing cabinet, or working off the information on our desk. So doing our long-term or working memory, and saying, okay, this is similar to something that I have in my working memory or in my long-term memory. Recall is when we are required to pull information that's been stored in our long-term memory. So in other words, the central executive comes across a new task. Say they're doing like you're working on a test. You've got the stuff that you've studied is sitting in your working memory, but you come across something that was perhaps talked about in a lecture that wasn't on the exam material, but that you need to remember in order to complete the exam material. That's called recall. Your chief executive is going to go to the filing cabinet, look through it, and say, okay, here we go. Here's the file for this information. And that's the process of recall, is bringing that long-term memory information and putting it in working memory. So recognition is seeing the information and being able to identify it in terms of what's in your working memory or what could be in your long-term memory. But recall is actually actively bringing information back from long-term memory. A large part of cognitive development in this period is language development, because that is a really important part of our growth as a human being, is learning how to utilize our native language. And so there are three sort of key perspectives on how we develop our language. The first is a behaviorist or a behaviorism view of language development. And essentially what this means is that we learn language through imitation and reinforcement. So over time we hear our parents or our caregivers or our brothers and sisters or our siblings talk to us, and we just start to mimic that. We imitate it. And over time, as we are successful at communicating, that is reinforced, that pattern is reinforced for us, and that is how we develop language. The second perspective is the nativist perspective. And the nativist perspective states that we have this innate universal grammar structure. So we have this internal structure that allows us to learn language, and all we have to do is learn the words to go in. And once we learn the words, we can establish innately the patterns that the grammar for our native language requires, and we're able to speak our own language. So in other words, we have the ability to learn language. It's innate in us. We just have to bring in the information. The last is the interactionist perspective. And this states that language is developed through a unique interaction between innate structures and environment. So in other words, it's sort of like the nativist and behaviorist viewpoints combined. We develop language because we have the innate structures in which to develop language, but it requires that we interact with, or that we somehow are exposed to and imitate and reinforce the language that we speak through interactions with our environment. In terms of talking, from about 2 to 12 months, we start to see a development in our ability to communicate verbally. So by month 2, we start to see cooing. So these are vowel-like noises like ooh, ah, yeah, ah. And this is the baby learning how to communicate with their verbs, or with their vowels, sorry. By 6 months, we start to see babbling, and this is when we have a consonant vowel combination. So ba, ba, da, da, ma, ma, na, na. We're combining, we're combining a consonant with a vowel. So a lot of times at this point, this is when people start to say, oh, my child had their first word. They said mama or dada. Well, maybe. Maybe they were talking about you. Maybe they're just combining a consonant and a vowel. Maybe it's that you're saying, can you say mama? That, because it's a consonant vowel combination, it primes that babbling reflex. By 8 to 12 months, we start to see joint attention. And maybe this doesn't seem like talking, but this is an important part of talking. This is the ability of an infant to attend to, or to view, or to pay attention to the same event or an object as a caregiver. So in other words, they're able to have some kind of focused interaction with another person. And this is an important part of language development, because part of talking and part of language is being able to have a focused interaction with another person. And then by 1 year, 12 months, we start to see first words. So with first words, there can be two different things that happen. The first is underextension. So this is applying words too narrowly. So, for example, you have a pet dog, and you say, only your pet dog is a dog. So you're out walking and you see another family and their dog. That is not a dog to your child. Your child is like, what is that? Like, that's a dog. And they look at your dog and say, no, this is dog. Because it's underextension. They're underextending the word. An overextension would be applying words too broadly. So say your pet dog's name is Sophie, and you're walking in the park and you see another family with dog, and you say, oh, look, it's a Sophie, but that dog may not be Sophie. That dog may be Chopper. And so that's another example. So a lot of times we learn as infants and toddlers, we learn words, but we may not understand fully what they mean or what all they apply to. By 18 to 24 months, so after the first year and then up to the second, we start to see a growth in vocabulary from 50 words to 200 words. It's a huge change in just a 1 year period. And we start to see what's called telegraphic speech. And this is two-word utterances which omit smaller, less important words. So cargo, instead of can we get in the car and go. Cargo. Is telegraphic. The reason it's called telegraphic is it kind of harks back to this, or thinks back to when we had telegraphs. And telegraphs, most of you are familiar with that, you wouldn't have a whole sentence. You would just do the important words because you're paying by the word. So you're going to try to get it as short as possible. So think of it like tweeting, tweet speech. You're saying as little as possible, only the important words. I just became relevant. Yay! We also start to see differences in communication styles. So the two styles that toddlers can exhibit are referential style, so using words with reference items. So black stapler would be an example of telegraphic speech and a referential style. Eat cookie. Go park. These are referencing items or actions. Expressive styles are words with social connotations, like mommy pretty, or mommy love me, or me love mommy, um, or um, or Darcy friend. They're they have social connotations. They're not They're not objectifying or referencing an object or an action. They're representing a relationship or a feeling between two people. On the other side of this developmental experience, we've got what the parents are doing, and around 18 to 24 months, we start to see child-directed speech, and these are short sentences, high-pitched, exaggerated expressions with clear pronunciation and pauses. So an example would be, "You're doing so well in developmental psychology." And the reason we do that is children react a lot better to high-pitched noises. Um, Maybe that wasn't short. That was short. It was maybe a little complex for child-directed speech, but you get the idea. Um, we all do it. Like, would you like to go to the park? When you do, when you have that kind of intonation, when you have the slow, like enunciated expressions, it helps the child understand what you're saying, and it makes them interested because children like things that are like high pitched and exciting, and so we do this, and it's sort of an instinct that we've developed that helps us communicate effectively with children. What's interesting is we also do it with dogs and cats and with old people. So I think it's sort of an instinct that we have that people who may not be as, or the animals that may not be as competent at language. So for older people are competent at language. We just kind of do it because I think we have this perception that they're not. But we'll talk about that more at the end of the semester. All right. Well, we did come in in 50 minutes, so good job, us. We get to be done early today. For class tomorrow, I want you to read pages 183 and page 209. I put on the syllabus that you should read supplemental reading for this class. I was wrong. I don't know why I did that. It's for this class. If you haven't read it yet, read it for this class. If you have read it and you're like, that makes no sense, why we need to read that? Well, that's why. Um, Next time we're talking about social and emotional development. And what I want you to think about, what are emotions? And then what are the adaptive function of emotions? We're going to be talking a lot about emotions. I love emotions. Spoiler alert, I have Inside Out figurines for class. I'm really excited. So get excited because this is going to be a fun, fun class. Remember that Friday we have our first movie night. This is optional. It's just for extra credit. You're welcome to come. Um, I'm pretty sure you can access this video or this movie online for relatively inexpensive. I will try to do some research today in the office and figure out if it's available on YouTube so that if you can't come into campus, you can still watch with us um, and get the extra credit. I don't know if it's on Netflix, but I'll figure it out. I will figure it out. I know it's on Amazon Prime, but I think for some of them you have to actually pay to rent it. So I'd like for you not to have to do that, but it may be the only option. And then there's nothing due. Just read, do your discussion boards, and let me know if you need anything. Darcy.Corbett Hall at ndsu.edu. I'll see you tomorrow. Have a great day.